Selamlar.
Merhaba hocam.
Merhaba. Selam Eylül. Bu ders Unity'den devam edeceğiz.
Merhaba hocam.
Geçen haftaki Unity session ile ilgili probleminiz, sorunuz var mı? Benim tavsiyem bir tur tekrar izleyip şey yapmanız. Kendiniz de yazmanız. Çünkü el hafızası biraz daha farklı oluyor. Hani istediğinizi istediğiniz yerde bulabilmek güzel bir şey. So, okay, we will continue with our Unity sessions. And for that, I will share my screen. There was a problem with my storage. It didn't have enough memory, so it couldn't do anything. This is why we're late, but okay. So I'm going to open our project from the last session, and we will add some stuff into that. Okay. So what did we have? Let me move those out of the way. So what did we have last week? So we had a moving cube, which also drags main camera along with it. Main camera is not the child of the player, so it watches the player from outside. And if we click A, it goes left. If we click D, it goes right. So this is what we had. Now we are going to fix the movement script. Also, we are going to change. We are going to add some barriers, so we can drive without crashing to them. And if we have time, we will also add some scoring system. So this is our plan for today. Before starting, I would like to go to a script that we have written. So it was player movement behavior. It opens in Rider editor since I have it preferred. And I will actually change my rider preference to dark. So it's inside appearance, and I will choose dark color. So it's easier for eye to see. Okay. So we had add force methods inside the update function. There are some problems with this script. First of all, it's unfortunately, there are some different lifecycle methods. We have mentioned start, which gets called before the first frame rendering. And we have talked about update, which gets called before each frame. But there's also one other kind of update method, which is fixed update. So now I should talk a little bit about this lifecycle method. So fixed updates, update is called when the new frame renders. So if frame takes a long time to render, then updates gets called less frequently. So updates is dependent on the FPS of the machine you are using. So updates can get called more if you have a high technology computer, but it can also be called less if you have an old computer or if you are using an old phone, etc. But there's a problem with that. If you are doing some physics calculations, you should not use updates, because imagine that you're adding force with each frame rendering. It's realistic. The game will look realistic if you are adding force continuously, and you are adding a consistent force. But if you have a changing DPS, and if you have a changing FPS, and because of that, if you have different time windows between each add force methods, then your movements script will rely on the computer you are in. And if, for instance, some some performance issue happens, then updates will get called less frequently, and because of that, your movements will be inconsistent, and you won't be able to add force whenever you click to A or D buttons. So did I make myself clear? I'm going to actually draw a diagram to make myself more clear. So, okay. I just want a line. So this is our timeline, okay? This is our timeline. And this is the frame rendering. So it's first frame rendering is here. Second frame rendering is, can I just copy this one? Okay, I can duplicate it. So second frame rendering can be here, for instance. And third frame rendering could be here. And I'm also, let's add some more. And this is my fourth frame rendering. So update gets called here, 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 and here, okay? And I call add force one time within each update. And because of this, if I were to try to move my character right between these two updates, these and these, I will only get to call add force once, and because of that, during this long period of time, I will just move a little bit of distance. And between these two time periods, add force will get called one time. And now I added a force much more dense, you know. So this is why it's not good practice to do physics operations inside the updates methods. Any questions for now? So I'm trying to copy those. Okay, now let's see how fixed update method gets called, okay? So it gets called once per physics engine tick, and physics engine in Unity gets called 100 times per second. It's not, it doesn't, you know, it doesn't change according to your machine. You can adjust, by the way, if you prefer, to call it more than 100 times each second. But normally it gets called once per, sorry, it gets called 100 frames. It gets called 100 times per frame. And because of that, if you, let's say, if you added force between these two fixed update ticks, I'm calling them ticks, it will add some amount of force. And between these two, the effect will be the same, since both time and the force is the same. So this is why we are using fixed update whenever we have time. Sorry, whenever we are working with physics engine of Unity. Any questions? This is important for you to understand. To make it even more clear, I'm going to debug.log time dot delta time. And I'm going to write fixed update is called. So whenever fixed update is called, I'm going to write fixed update into my console. Okay. And also I'm going to add time.delta time at the end. And time.delta time is the time difference between the last seconds that the frame is that this method got called, and now. So the completion time in seconds since the last frame. Basically, it's the proper definition is here. And now I'm going to make something similar here. Now, every time update function gets called, I'm going to write update is called plus the delta time. And for convenience, I'm going to disable these two. So I won't be able to move my character, but I'm just going to show you something. I'm going to clear warnings by clicking clear button. And if I hit play, there will be a lot of different callings. I'm going to hit pause. So, okay, as you see, updates is, I mean, if you see updates methods, the delta time is changing, right? So it's different every time. But fixed updates is called after 2 milliseconds every time. You see what I mean? So another way to make this more clear is hitting collapse. Collapse basically looks up at all console messages, and if they are the same console message, it just shrinks them to just one message, and it writes the number of this message at the end. So this message got called more than 300 times. But as you see, updates callings are really based on performance of my machine. So is that all clear for you?
Yes, I believe it is for me.
Okay. This is one important.
Can I ask something?
Sure, go ahead.
It looks perfect to use, fixed update method. Is there any good side of using updates, normal update in our games?
Yeah. I mean, for instance, input handling is. I mean, inputs. Capturing inputs are done in the update function. So actually, if we look back to our code, we should actually capture our inputs within update method, and then moving our character inside fixed update method. For simplicity, I'm not going to do that right now, but I'm going to instead take these codes, cutting it with command X and pasting it with command V, and I'm going to move my character inside fixed update function. But this also has a problem because, like I said, I'm not capturing the key press in the exact time. So if I mean, in a real game, I will be pressing A like this and D like this. You know, it will be continuous. So it will capture one of them. But if I had a jumping mechanic, for instance, if I hit space one time and then one time and then one time, there's a possibility that fixed updates won't catch this one input event. So this is why I should capture my input here, put it inside a variable, and then according to this variable, I should jump or move right or move left inside fixed update. Like I said, for this lecture, it's I mean, more than enough to write it like this, but I will be fixing this next lecture probably. This is another lifecycle method, like I said. Actually, to be concise, I'm going to show you all lifecycle methods at once right now. So I'm I mean, I call these, building blocks of Unity, and this is one thing that you should make yourself familiar with. This may look, a little hard at first, but not all of those are important for you. In fact, for practical stuff, you should learn about 7 or 8 of them. But if when you are getting to know Unity more and more, and when you are trying new stuff, you should from time to time visit this page, and you should try to see where you went wrong. So yeah, before everything, awake method gets called, and awake methods gets called inside all of those scripts in the game, and it is used to initialize some important variables or some important systems that other methods use. For instance, if I were to reach and manipulate a data in start, I should initialize it first, and I should do that in awake function. There's another popular method which is called onEnable. OnEnable gets called when the script or game object is enabled like this. So now it's disabled. When it's disabled, onDisable gets called. When it's enabled, onEnable gets called. It's basically the same when you are enabling and disabling components, or if you have a script, your script has a tick like this on the left side of it, and it can, you can enable and disable it also. So onEnable is also important. Reset is called when the script is attached and not in play mode. It's sometimes some methods even get called when you are doing some stuff in the editor, and reset is one of those. So when you attach a script inside a object, you can call reset. I never used this method before, but it can be useful if you are adding this script player movement behavior to an object like your player. As you see, after adding the script, I had to manually attach player RigidBody to my script. I could do that automatically within onReset method. And when I remove this and then re-edit inside my player, then onReset could automatically find the RigidBody and update it. Not update it, but how can I say? Find it and make it ready for later use. Okay, but reset is not that important. Awake, onEnable, and start is really important ones. And start is only ever called once for a given script at the start, before any other frame. Okay, so this is also for initialization, and this is why usually you combine awake and start in scripts to, you know, supply some data inside awake and adjust this data inside start. And let's jump into the physics part. So it looks really huge, but not all of them will be important for your task. Fixed update is really important. The physics cycle may happen more than once per frame if the fixed time step is less than the actual frame update time. So this is a bit confusing. Let's reread it. So it says physics cycle may happen more than once per frame. Like I said, if your FPS is, you know, 30, but the, you know, physics engine gets called 100 times, then your fixed updates will be called almost 3 times per frame. If the fixed time step is less than the actual frame update time. So frame, yeah. As you see, in my case, my fixed updates step is smaller than this one, for instance, and this one also, but not this one. So they are intersected, you know. Fixed updates callings and update callings are intersected. Sometimes if I have poor performance in my computer or mobile, fixed updates gets called more frequently, consistently. And okay, if you have a you know, animation cycle, you should check out this part. So this is internal animation update, and there's one internal animation update cycle too, and between that there's some internal physics update. So if your animation is dependent on the recent physics updates, then you should you know, do that, you know, do some calculations here. I mean, we are not in my company using animations frequently, so I mean, until you jump into animations, all of those will be, you know, not important for you, and also this part will not be important for you. But OnTrigger and OnCollision is really important. Like I said, one of the main benefits of using a game engine is so it calculates collisions for you, and you know, if you have some objects that collide in your game, you will definitely use this one. And also OnTrigger is getting used, you know, quite often. And these two are mostly to calculate the relations between two different objects. The reason there's XXX on the right is there are different OnCollision methods. One of them is OnCollision enter. One of them is what OnCollision? Let me check. OnCollision. So it's Rider has nice IntelliSense that completes the code for you. So there's OnCollision enter, there's OnCollision exit, OnCollision stay, and there are 2D methods, 2D versions of those. So there are 6 different OnCollision methods, and these are self-explanatory. So OnCollision enter gets called when 2 objects begin to intersect with each other. There's OnCollision exit, which gets called when 2 different objects get separated from each other, and OnCollision stay gets called when they are staying together. They are collided together. And 2D versions of those are for better performance in 2D games. So if you have a 2D game, you use those instead. In Unity, as a general rule, if you have a 2D game, you just write 2D at the end of your methods and variables. So for instance, this vector 3 is 3-dimensional, vector 2 is 2-dimensional, etc. Okay, and moving back to life cycles. There are some input events. So as you see, physics updates gets called before input events. And there are, as you see, some XX again. This is because there are different on-mouse methods. If we use IntelliSense of Rider, you can see different mouse movements that we can capture. So mouse down gets called when we press the mouse button. Mouse drag gets called when we press a mouse button, then drag our mouse while it's pressed. On mouse enter will be called when I am starting to hover my mouse on top of some object or some UI elements. On mouse exits will get called when the mouse is not any longer over the collider. There are explanations on the right too, actually. On mouse over will be called every frame while the mouse is over the collider. This function can be a coroutine. I mean, this part is not important for you right now. On mouse up is also self-explanatory. When you release the mouse button, this function gets called. And on mouse up as button is only called when the mouse is released over the same collider as it was pressed. So, I mean, this gets called when you are, using something as a button. Everything clear? Okay. And now we had our initialization. We had some physics calculations. We handled our inputs, and now we jump into our game logic. And now, by the way, I told you wrong, Erdem. So as you see, input events are captured not inside updates, but before update, right before update. So still, it's more appropriate to use input events inside updates, but I mean, it shouldn't confuse you. It's not getting called inside update, but it gets right before the update. Okay. Yield null, yield wait 4 seconds, yield start coroutine. Okay. So these are for the tasks that require some time. So in C#, if you want to, let's say, start a I don't know, chronometer inside your game, you can use a coroutine. Coroutine is a routine, um, a list of events that work separately from your main script. So as a separate flow, I mean your main logic, your main game flow will be called from top to bottom. And if you start a coroutine, it will work in parallel. And when the coroutine is finished, it's notifies your main flow, and you can react accordingly. So if you have a timer, for instance, your main game logic can start at timer, and when the timer is down, I mean, if you are counting from 10 to 0, it can notify back to the main script, and maybe player can lose the game when the timer is down to 0 seconds. So you can do stuff like that inside game logic, inside update. And there's also late updates, which how can I say, which waits for update function to finish and then adjusts the scene according to the objects in the screen. So late update can fix animations, for instance. And there are some optimization methods which are useful when you're rendering scene. As a general rule in game development, if something is not visible to the player, you should not waste resources to render this object. And because of that, you should cull the objects that are not visible to the player. So culling is basically not rendering the objects that are not visible to the player. And this is, I mean, the Unity handles this for you also, but you can adjust when things become, invisible and stuff. For instance, in some games, there are some objects that look really basic, but when you get close to them, they become, more detailed. I guess you can handle those kind of stuff here. But like I said, this won't affect your this won't affect you, and on the row gizmos is not very popular also. It gets called while you are working in the editor only, and on GUI is called multiple time per frame updates. It gets called when you are rendering graphical user interface, but this is also not important. Okay, if you want to wait for end of frame, you can create a coroutine for that, and it will get called here. On application pause will be called to notify scripts that the application is paused. On application pause is called after the frame when the pause occurs, but issues another frame before actually pausing. And on application pause, on application quits, on disable, and on destroy are also really important. So on application quits happens when